All right, well, where does this go next? Because we started off this class talking about rate of change. So for rate of change expressed as delta y over delta x, we know that we cannot just simply let delta x equal 0. We can't divide by 0. But what you got today was you got the apparatus that's going to allow you to evaluate this expression as delta x is getting close to 0. So we will be able to evaluate using limits. And what we really want to take here is we want to take this particular function, this delta y over delta x, and we want to be able to say, what is the limit as delta x approaches 0? And this right here is actually a really critical idea to calculus. We'll spend several topics getting really good at evaluating limits, but remember that the reason that we're going to be doing so, at least here in the very short term, is we want to be able to take this expression right here because that is going to tell us the instantaneous rate of change of functions. And so that statement right there, the limit as delta x approaches 0 of change in y over change in x, will establish the instantaneous rate of change of a function at a given point. And in fact, not only will we look for this to give us the instantaneous rate of change of a function at a given point, but one of the things we'll discover much later on, and don't feel like you have to know this right away in terms of where you're at in calculus, we'll actually use this right here to also give us the rate of change as its own function. So for each particular function that we're going to be looking at, we're actually going to use this expression right here to establish its rate of change as its own separate function. And we'll get into that when we talk about the idea of derivatives. But for right now, just get really good at knowing and understanding that limit notation, understand the idea it's trying to convey, and understand what it means whenever you see that limit notation.